differentiate y equals -3 times the secant of theta minus tangent of theta, all of that raised to the 3/2 power. All right, so this is a composite function, right? So we know that we're going to have to use a chain rule here. Of course, we also have some trig functions that we have to deal with, right? Okay, so what does the chain rule say? Oh, also we have a -3 out front here. Now the -3, as long as you remember to multiply by -3 at the very end, right? Just remember to do that. But what are the composite functions here, right? I guess that's the first thing we should ask. Okay, so you realize that anything in parentheses usually, right? That's always going to be the inner function, and that's going to be the outer function here, right? In this case, the power. So if f of x is, let's call it x to the 3/2 power. Okay, I guess we can call it -3 x to the 3/2 power, right? Then the inner function here in this case, right? That's going to be the secant of theta minus tangent of theta, right? Essentially, this is what goes into that x over there, right? Okay. So what does the chain rule say? Right, we need to find the derivative of f evaluated at g. Okay, so we're going to take the derivative of f and then just stick that in there as the final, times the derivative of the inner function, right? The derivative of g of x. Okay. Now in this case, well, I guess we can do this work on the side, right? What is f prime of x? What is the derivative of the outer function? Well, use the power rule. We'll bring the 3/2 in front, multiply that, so we get -9/2 x to the 1/2 power. Okay. And what is the derivative of the inner function? In this case, g. So g prime of x. Okay. Now with the minus here, we can just take the derivative of each one separately, right? The derivative of secant is secant of theta, tangent of theta, and the derivative of tangent theta is secant squared of theta. So let's go back. What is dy dx going to be then? Okay, so what is the first step? We take the derivative of f, so we did that already, right? It's -9/2, but instead of putting x here, right, we have to evaluate it at the inner function. We'll plug g in there, so secant of theta minus tangent of theta, all of that to the 1/2 power, times the derivative of the inner function, which we already have right here, right? So there we go, secant theta, tangent theta, minus secant squared of theta. Okay. Now, of course, we can factor out the secant from here, maybe do a little bit of simplification, okay, right? But for the most part, right, this here should be our derivative.